That is a Boeing 747, but something about it just isn't quite right. Look a little closer. This plane has 5 engines. And that 5th engine isn't there just for extra power. It's there because some of the most advanced jet engines ever built are too dangerous to test on a normal airplane. Engineers created a flying laboratory capable of testing these engines from 40,000 feet above the earth. And the aircraft they chose to do it in was one of the rarest Boeing aircraft ever built. This is the story of Pratt Whitney's flying laboratory and why this 747 flies with a 5th engine. Welcome back, everyone, to Aero Exploration. My name is Jim, and on this episode, we're going to be talking about a really unique 747 that Pratt & Whitney uses to test engines. To understand this 5-engine 747, we have to go back to the 1970s. The world was in the middle of an oil crisis. Fuel prices were rapidly on the rise, and airlines suddenly needed to find an aircraft that could fly them further with less fuel. At the same time, ambitious airlines like Iran Air and Pan American World Airways wanted to connect cities separated by enormous distances. Iran Air had hoped to operate nonstop flights from Tehran to New York and to Tokyo, routes that had pushed the limits of existing aircraft. Now, the queen of the skies, the Boeing 747, had already revolutionized air travel, but standard versions were designed to carry hundreds of passengers and not to fly extreme long distances with lighter loads. So Boeing engineers came up with a new idea. So instead of making the airplane bigger, they made it smaller. Led by legendary engineer Joe Sutter, Boeing created a shortened version of this jumbo jet. The aircraft was called the 747 SP, which was short for Special Performance. Engineers will remove more than 47 feet of the fuselage from the original 747 design. This new aircraft will carry fewer passengers, but it was lighter, faster in the climb, and it was capable of flying further than any wide-body airliner at the time. To maintain stability, Boeing would have to redesign the tail with a much larger vertical stabilizer and made several structural changes to reduce the weight. It was shorter, more compact, and almost stubby compared to a standard 747. But despite the strange appearance, the 747 SP was an extraordinary machine. It would enter into service in 1976 and quickly began setting long-distance records. Pan Am would use it for nonstop flights between New York and Tokyo, and one delivery flight flew from Seattle to Cape Town, which is more than 10,000 miles, without stopping. Now, despite this impressive performance, the 747 SP was really a niche aircraft. Only 45 of them were ever built. As newer and more efficient aircraft entered service, most of these aircraft were eventually retired. Many ended their careers parked in desert storage facilities. One found a remarkable second life as NASA's Airborne Observatory. But by the end of the early 2000s, the era of the 747 SP appeared to be ending. So now developing modern jet engines is one of the most complex engineering challenges that there is. It can take more than a decade and cost billions of dollars. Companies like Pratt & Whitney design engines containing thousands of precision components. Inside these engines, turbines spin at incredible speeds, temperatures rise, and everything has to work flawlessly for tens of thousands of flight hours. Engineers end up testing components extensively on the ground. They run the engines at massive concrete test cells. In these cells, they can simulate a lot of different conditions. They can simulate airflow, temperature, and different pressures. But there's one problem. A test cell is still not the sky. It just can't perfectly recreate real-world flight conditions. Thin air at altitude, rapid temperature changes, severe turbulence, heavy rain and hail, and the list goes on. As you can imagine, the last place that you want to discover a design flaw is on an airplane full of passengers. So, before a new engine ever enters airline service, it has to be tested in flight. And this is where the flying test beds come in. For decades, engine manufacturers have modified aircraft specifically for this purpose. Pratt Whitney had previously used other Boeing aircraft for testing, but by the early 2000s, new engines became larger and more powerful than before. So they needed a new platform that met the requirement. The plane had to be powerful, had to be capable of flying high and fast. It would have to be large enough inside to carry an entire airborne engineering laboratory. And the answer turned out to be hiding right in plain sight: the rare and largely forgotten Boeing 747 SP. So Pratt & Whitney then went on to acquire 2 retired airliners and began transforming them into flying testbeds. The most obvious modification is a 5th engine. It's mounted on a custom pylon between the fuselage and inboard engine. The unusual location was chosen very carefully. It keeps the test engine clear of the airflow disturbance from the other engines, but the real transformation happened inside the cabin of the aircraft. You step through the doors and you won't find passenger seats. Instead, you find rows of equipment racks, computers, and monitoring systems. These aircraft are effectively turned into flying engineering laboratories. Now, up to 20 flight test engineers can work inside during a mission. Their screens monitor the measurements from sensors installed throughout the engine: temperature, pressure, vibration, fuel flow, and acoustic data. Every detail of how this engine behaves in flight is recorded. Now, to test this performance, the flight crew has to work closely with the engineering team. So during these test flights, the pilots might be asked to perform steep climbs, rapid descents, or extended cruise at high altitude. Remarkably, the engineers can control the test engine independently. They can start it, throttle it, even shut it down completely, all while the aircraft continues to fly safely on its original 4 engines. All right, so what does a typical flight look like? Well, they begin at the Mirabel Airport in Quebec, Canada, where Pratt & Whitney operates its flight test program. The aircraft will take off using the 4 standard engines. Once safely airborne, the engineering team will bring the 5th engine online. The aircraft will then head over designated test areas over remote northern Canada. Here is where the engineers begin pushing the engine through a wide range of conditions: climbs to over 40,000 feet, rapid power changes, simulated takeoff and landings. They will even deliberately fly through natural icing conditions, which then allows supercooled water droplets to freeze through the engine's fan blades. In doing this, it helps them verify that the engine's anti-icing systems are working correctly. Other tests will examine how the engine performs at extreme altitudes. At cruise altitude, the engineers may shut down the engine completely, and then attempt to restart it in the freezing and thin air. This is a critical safety test, and doing it on a 4-engine aircraft provides a huge safety margin. Throughout this entire flight, the engineers are validating computer models and collecting enormous amounts of data. For Pratt & Whitney, these tests have helped them confirm major improvements in efficiency and noise reduction. Every hour of flight testing helps the engineers identify potential issues long before the engine enters commercial service. From record-breaking airliner with a unique story to flying engineering laboratory, the Boeing 747 SP found a second life that may even be more important than its first. Before a new jet engine ever carries passengers across oceans, before it powers the next generation of aircraft, before it appears under the wing of an Airbus or an Embraer, the design almost certainly spent hours flying on one of these aircraft first. A 5-engine 747 SP that exists for one reason: to test the future of flight. Well, thanks so much for joining me for an inside look of Pratt & Whitney's Boeing 747 SPs used for engine testing. If you enjoyed this video, make sure to like and subscribe to the channel, and leave me a comment if there's anything in aviation that you want me to check out next.